Hello, geometry students. Today we're going to talk about the measurement of the arcs of a circle. So how do you find the arc measurement? Well, the measurement of an arc in degrees, the curviness of the arc, has the exact same measurement in degrees as the central angle. So if you look at this black central angle, that central angle cuts this arc, this red arc. And the measurement of our arc RT is going to be equal to the measurement of angle RST. If you want to know what the blue arc is, you can take 360 degrees and subtract out the measurement of the minor arc. So to get the measurement of the major arc, 360 minus the minor arc. To get the measurement of the minor arc, it's exactly equal to the central angle. And the measurement of a semicircle is always 180 degrees. Some vocabulary we're going to need in this video. The first thing is adjacent arcs. Adjacent, right next to, but without overlapping. So here's an example of two adjacent arcs. Arc AC is adjacent to arc CB because one begins where the other ends. Just like adjacent angles and adjacent areas, these arcs, one ends where the other begins. And notice that here's an example of two arcs that are not adjacent. They overlap each other. And here is an example of two arcs that are not adjacent because they don't touch each other. There's a gap. So there can be no gaps and no overlap if you want the arcs to be adjacent. If they are adjacent, then we can use the arc addition postulate, which should remind you of the segment addition postulate we've learned previously and the angle addition postulate we learned previously. It's the same idea. As long as there's no gap or overlap, if you have two adjacent arcs, the measurement of one arc plus the measurement of the other arc equals the measurement of the whole larger arc. So part plus part equals the whole. So how would you use this in a problem? Well, what is the measurement of arc BC? Well, the arc is congruent to the measurement of the central angle. So that would also be 32. This arc is 58, arc CD, so this angle here would be 58 as well. What about the major arc? ABC, so A through B to C. Well, that is a semicircle because a segment AC is the diameter. So ABC would be 180 degrees. And arc AB, how could we figure that out? Arc AB, to figure that out, we see that arc A, if we go all the way from A through B to C, that's 180. So 180 minus this arc we already said was 32 will give us what remains, 148. So pause and practice finding using arc addition postulate and the knowledge that the measurement of the angle, central angle is the same as the measurement of the arc that is cut by that angle. Pause, do this on your own paper, and then press play for your solution. The central angle is congruent to the measurement of the arc that's being cut. Here we have a semicircle, so to get RS, we would do 180 minus that 77. And here we see that if this arc is 28, this angle is 28. And if we wanted to find, we see the whole semicircle is 180, so 180 minus this 28 would give us the remaining arc PQ. We could also add together, so for P through R to Q, P through R to Q, we would add up 77, 103, and 28. Or you could say we'd add 180 and 28. And to get P through Q to R, P through Q to R, it's the whole circle minus 77. So there are lots of ways to think about it. So pause and practice, and then press play for the solutions. We see that for this one, we have a semicircle, 180 degrees. We see for this one, we have 90 degrees. We see for this one, it's 128 degrees. We see for this one, we can add that, we see that linear pair, so that's 90, this is 90, and then we can add this that we've already found to be 52. So 90 plus 52 will give us our measurement. Here we have the whole 360 minus this 90 to get 270. And then here we have the whole circle minus the 128 will give us our answer here. Same here, we have the whole circle minus this 90 will give us our answer here. And we see for this arc, we can see it's right here, which is 128 plus 90 will give us our answer here. Congruent arcs are arcs that have the same measurement and are in the same circle or in congruent circles. So pause and use all we've learned today and apply some of your algebra skills. Pause the video and then press play for the solution. We know that these are a linear pair, and so their measurements will add to 180, and we can create our equation and then solve for C. Pause, practice on your own paper, and then press play for the solution. We know that the degrees all the way around the circle are 360 degrees, so we can add those up by arc addition postulate, and we can create our equation and solve for X. I'll leave you with this picture of perennial hibiscus and wish you a lovely day.